You'll find PV is a very useful function within Excel that you'll employ greatly, especially during this class. Within this tutorial, I'm going to talk a bit about the syntax of the present value function and how to understand the intricacies of assigning arguments. So just to start, there's a few different ways you can access the PV function. The one you are obviously familiar with is just to type an enter equal sign and then type PV for present value and start with a bracket. And when you start with your right-facing parenthesis, you'll see a bracket. You'll see the full syntax for this function as well as each of the arguments. If you're not familiar with the arguments and syntax, you need some help. What's always nice is if you push your mouse down to where there's a quick cheat guide for the syntax of the present value function, you can left click on the PV and you'll notice that once you place your mouse down, each of the arguments will turn blue. Now if we want to have payment or number of periods go blue, then we'll have to enter commas till we move to the correct argument. But we'll just left click on PV. And so what you see is PV function. There's a description of the PV function, what it's calculating. And the quick point is that it's calculating with periodic constant payments relative to a constant discount rate or rate of interest. As we go down, you'll see there's an explanation of the syntax. So we identify the function PV with the rate, number of periods, payment, future value, and type argument, which we'll discuss shortly. And so why this is useful, Excel will explain to you how the software recognizes the arguments that you enter. This is chiefly important that when subperiods come into play, you understand how Excel, the software in the back end, is set up so that you can enter the arguments correctly. So there's a quick overview here. There's an overview of related functions. And then there's even a description of how Excel calculates for the present value. So I'm sure this will be quite useful for many of you. In addition, if you want to access the present value function, you can also left click on the insert function and you can scroll down if you're interested only in financial, or if you want to look at most recently used, we can click most recently used and PV pops right up. Otherwise, under all functions, we can scroll down to present value. And we have a nice pop-up that walks us through each of the function arguments where we can enter the rate, periods, payments, and so forth. In addition, we can go to the Formulas tab, and there's a subfield for the function library, and we can click on Financial. And from here, scroll down to Find PV, and we'll receive the nice. So in this example, we're going to solve for lump sum, annuity, annuity due, and a lump sum plus annuity due. The arguments of the PV function are rate, and rate is stated as annual. If there are subperiods, we need to divide rate, that is R within the formula that you're used to seeing, by the number of subperiods, which is n. The number of periods is number of annual periods, so if we want subperiods, we're going to have to multiply by the number of subperiods. Payment is also regularly occurring annual payments, so if there's subperiods, we need to divide payment by n to have the subperiod payment. FV is for the future payment received at the end of the period. So this is particularly applicable when we're solving for a coupon bond. And type indicates if the payment's received at the beginning of the period or the end of the period. By default, the payment is received at the end of the period. This is the most common. And if this argument is omitted, it will by default be a value of 0, which is again at the end of the period. If you have something like an annuity due that you're trying to solve for, you would want to enter 1 for this argument. So let's start with the lump sum. We'll start with our argument, equal sign, PV, and we first have to enter our rate. Now notice in this example there are subperiods. We have a future value of 50,000, T in years, so 10 years, N has 4, which is 4 subperiods with the year, which means quarterly. There's 0 payments throughout this period, and the annual rate of interest is 7.5, so we'd have to divide that by 4. So our rate is 0.075, and we're going to divide by N. Next, number of periods is years, but we also need to account for the number of subperiods. And so what we're telling Excel right here in this moment is we have annual interest of 0.75, but we're identifying the periodic rate. We're telling Excel, here's the periodic rate. Excel doesn't know whether you're working with an annual, quarter, or some other type of subperiod. So all Excel can recognize is the periodic interest and the number of periods. So we're telling Excel the periodic interest, which is 0.075 divided by 4, and the number of periods are T times N, in this case 40. There's 0 payments. Now we could leave this blank by default, and that would look like this, where we just type a second comma and we move on to the next argument. Just for good form, we're going to indicate payment is 0. The future value is indicated above is 50. Now notice one thing you don't want to do. Let's say you're used to typing commas. You don't want to type in 50,000 and comma. What this does is it pushes you to, by placing a comma in 50,000, you're then telling Excel to move on to the next argument. So if you're going to enter 50,000 manually, you would have to do it as such. Lastly, we're talking about the type of payments or when the money is received. It's at the beginning of the period or the end. It's at the end of the period. There's nothing, in this case, like an annuity due, so we'll type 0. Again, by default, we could just leave this one. So we see that the lump sum or the present value of receiving 50,000 in 10 years from now with quarterly interest at 7.5% has a present value of $23,782.90. For the annuity, we'll start off again, equal sign present value. And we're selecting rate. We're dividing it again by the number of subperiods. We want to tell Excel that we have 10 years, but we need to multiply by the number of subperiods, so we are accounting for all periods. There is a regular payment of 1,000. We're going to assume that this 1,000 is annual, so we then want to tell Excel or indicate that the periodic amount. So if we're receiving quarterly payments and it's $1,000 annually, that would be $250 each quarter. And so dividing by payment by N, now Excel identifies the payment as being $250. There is no future value. We can just leave that blank, or we can reference the 0 value above. And lastly, the payment is being received at the end, since this is an ordinary annuity. So we can see that an annuity that pays us $250 every quarter for 10 years with a discount rate of 7.5% has a present value of $6,991.22. Now if we go to the annuity due with the exact same values, we could simply copy and paste, but we'll, just for practice, repeat this process. So we're going to identify the rate. We're going to divide by N. We'll go to the number of years, multiply times N. So again, it was R divided by N, T multiplied times N. Now we're going to tell Excel that there is a payment of 1,000, but it's quarterly. There's a future value of 0. And in this type, it's an annuity due, so the payment's received at the beginning versus the end. So we'll type a value of 1 to indicate the annuity due. So we can see that the annuity due has a value of $7,122.31. We can double check this value by referencing the annuity and multiplying 1 period's worth of return. That would simply be R divided by N. And so since we get the same value, we know we're on the correct path. Lastly, we're going to solve for a coupon bond, which is a lump sum plus an annuity. So we'll start off with a PV function. We're going to indicate the discount rate. Now in this example, remember, there's a coupon rate and there's a discount rate. The rate here is the periodic discount rate. The coupon rate is solely used for calculating the coupon payment. There are subperiods, so we're going to divide R by N, and then we'll indicate number of years and multiply by N. In the case of the payment, we've already calculated the coupon payment. The coupon payment is simply the face value times the coupon rate, so 1,000 times 8% is 80. But we know that this payment is received semi-annually, so we need to divide by 2. The future value is 1,000, and we're going to say what the coupon bond is received at the end, so we'll indicate a value of 0. So our coupon bond has a present value of $1,195.83, and we would expect that it would be selling above face value because the coupon rate exceeds the market rate. We could also double check this by finding the value of an annuity that pays semi-annually that's $30 more than the market. Why do I say $30 more? Well, notice our coupon rate is 8%, so it's making a payment of 80. The market bond is equal to its face value of 1,000 times 5%. So the market bond pays 50. The difference between 80 and 50 is 30. So we could keep all these same values. The only difference is we'll change this to a 30. Remember, with the bond, the $1,000 is the same either way, at the beginning or the end. So we're going to enter a value of 0 just to see how these two differ. And what we should find is a semi-annual annuity that pays $30 annually, 5% discount rate, should have a value of $195. And there we go. So hopefully this is helpful. If you need to, go ahead and watch it or this video again, or just back it up. Again, if you have difficulties with the present value function or the syntax, remember, just type in the PV. The syntax will be presented for you. If you're having challenges with the first argument, you can just go ahead and click on it. And Excel help should pop up, and you can scroll down to each of the functions. If that's still not working, also remember, while you're entering the present value function, just left click on the FX symbol, and the function arguments will pop up with a nice explanation.